Hello and welcome to the section 7.1 lecture today. Today we're starting our new material for our sixth micro term, what I am kind of counting as the second term of Algebra 1 Part 1. So if you've had a hard time in the first term, you have time now that you can kind of flip that around and let's work on doing better in the second term. If you made it through the first term, okay. Really, it is kind of a reset for you, but I don't want you to take it too easy. Otherwise, you might lose your momentum, and then not do as well in the second term. So let's make sure we take this seriously and really work on getting through it. So in section 7.1, we're looking at finding slope on a graph. This entire unit is going to be about finding slope, and today is going to be specifically if we're given a graph. Okay, so let's just take a quick look, and this is going to sort of identify the concept for us. And the idea is slope. For some reason, mathematically, we use the letter m to denote the slope, but it says that the slope m of a non-vertical line is the ratio of the vertical change, what we call the rise, to the horizontal change that we call the run. And when we're looking on a graph, we're going to get to this equation one of these days this week, but for today we're looking at a graph, and we want to compare how far up does it go, and then how far over does it go for rise and run. And we want to put that as a fraction. And our main idea today is going to be just the rise over run. Another way we think of that mathematically is we think of delta, a triangle symbol with a y, as the change in y over the change in x. How much does y change divided by how much does x change? All right, and for me, I'm always going to be looking left to right. I'm going to find 2 points on my line and then always look left to right. So, how to find the slope of a line? Thinking there were supposed to be a couple lines on there, but that's okay. We'll get some out there and call it good. I don't know if those didn't copy in or what. So let's go ahead and look at a line. We're going to take it this way. And yeah, that looks okay. And then I'm going to take another one and go, I don't know, kind of from here to maybe a little bit more. Yeah, that looks okay also. So when we're finding slope of a line, the first thing we want to do is kind of step number one, find or even identify 2 points on the line. So I want to find 2 points, and I don't care how far apart these are, but I want to make sure that they're really good grid points. And what's going to help me with that on these two at least is I'm going to try to do this both at once. I'm going to try to bring down the thickness of these lines a little bit, because the thicker the line, the tougher it is to tell. And can I just bump that up slightly? Yeah, that looks a little bit better. And let me look here. I think that's okay. We'll at least do our best on these ones. But obviously, the thicker the lines, the harder it is to tell if they really cross. And so what I mean by that is I'm looking for, and I'm going to use this one because I think it's a pretty good one right here. And I'm looking for, does my black line cross this red intersection of grid lines? Based on my drawing there, it looks like it misses it just a little bit below. But if I look back at the graph itself, it seems like it hits that. At least in my eyes, it's supposed to. And what you're going to find is that it's easiest to look at a close intersection from this one. I don't want I'm going to today, but just out of curiosity. I don't necessarily want to look for one way over here and then one way over here that's going to cause me to do something else towards the end. But just a quick look, I think I get a really good one here at 0, 1. Okay, I think I get a really good intersection right there, and I really like that one. So that's the one that I'm going to pick. Now I want to count my rise over my run. So once I find my 2 points, step 2 is starting left. I'm going to say starting at the left. I'm going to count my way up. I'll say up or down to get level with the other point. And here's how I think of that with the other point. Let me write this. I can't really write one thing and talk about another. I want to try to envision that I'm sitting in an office building and I have an appointment in somebody's office, and I'm standing right now at the elevator. And so this is me standing on the elevator. This is where that person's office is. This is where I have to get to. And in an office building, I can't just walk along this diagonal line to get there, right? I have to go up in the elevator and then down that hallway until I get to his office, okay? So in essence, step 2, I'm counting how many floors up am I going in the elevator. And so for this one, it's going to be up 1, up 2, up 3, up 4. Okay, it looks like I'm going up 4. And I'm going to go ahead and write that as I'm going up 4. And I'm going to think of up as positive. So I'm going to say that's a positive 4. The next thing I want to do is, now that I've come out of the elevator, I want to know how far down do I have to go until I get to their office. Okay, so step 3 is count right. If I start at the left point and I move up or down, I'm always counting to the right. So I'm going to count right to the other point. So from here, I'm thinking about, in my kind of office analogy, I'm thinking of, I went up so many floors, and now I have to go across so many doors until I get to his office, okay? So from the elevator, I'm passing 1 door, 2 doors, 3 doors, 4, 5, 6, 7, 8 doors. 8 doors to get to his office. Okay. And again, if I start at the left point, I'm always going to be counting right. That's why I say count right to get to the other point. And then step 4, we're just going to write our slope. Where m is equal to the rise over the run. Or in my analogy, number of floors, number of doors. I think of floors and doors. I had to go up 4 floors and over 8 doors. So I'm going to go up 4 over 8. Now that one does reduce because I didn't pick the 2 points closest to each other that were good intersections. We can kind of see that right here would be another good point to use. And if I was going from this point to this point, I would only go up 1 and over 2. Well, in the same manner, 4 over 8 reduces to 1 over 2. But this is a very valuable skill to have, is to be able to reduce my fraction to not require me to pick the closest 2. Because maybe I had my doubts about this point, or maybe I just didn't see it. A lot of those things happen. So pick any 2. You don't have to pick the closest 2 points. Okay, but I do get very picky, and there are a lot of different slopes here that can be just minorly off on some certain grid points. So you'll want to make sure that you kind of meet my level of pickiness to make sure that you do the problem right. Don't just look at it really quick and say, it looks like it goes up 1 over 1. I'm good there. Because up 1 over 1 would be a lot different than up 1 over 2. But when we get to things like, if I think of a slope of up 1 over 1, it's actually really close visually to something like up 3 over 4 or up 10 over 11. Like those are very close. You want to make sure that you get it right and don't miss it for something silly. Okay. On my next one here, I want to find my 2 points. I really like this one. I think that looks like a really good point. And from there, it's kind of up to you. Maybe it's this one down here that I like the best. I don't typically like ones on the boundary the best, at the very bottom of my graph here. But I think this one works out pretty well. And they might be the closest to, they might not be. All right. I did draw these lines on here, so they're going to be a little lacking in precision anyways. All right, so let's go ahead and do the same thing. I'm going to start at the left point. This time I have to count down, so I'm like already up towards the top of whatever building. Maybe I arrived on a helicopter, and they got an elevator on the roof, and I got to figure out how far down I got to go. This one's going to be a pretty big number. I'm going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I believe that's right. Yeah. Another way to do that is look at my y coordinate goes from a 4 to a negative 10. So that's covering 14 units. Now, how far over do I go? So I finally got to his floor. I had to go down 14 floors. And then I'm going over 1, 2, 3, 4, 5. So I went down 14. I'm going to treat that as a negative, and over 5. So this is a really good example that I bet a lot of people would have looked at some of those points in the middle and said, oh, that looks good. For instance, if you were to pick this point because you thought it looked good, you would get something like down 1, down 2, 3, 4, 5, 6 over 2. And down 6 over 2 would simplify to a slope of negative 3 over 1. This one is not 3 over 1, it's negative 14 over 5. There is a difference there. And down 15 over 5 would have given us that slope of 3, or negative 3. So I just write it, negative 14 over 5, and I'm good. I'm done. So that is all we're doing today. I know that I really made it sound a little more difficult than it is, but that's the main thing of today. Pick 2 points, start at the left point, count up or down, until you get on the same level, and then count over. If you like the floors and doors analogy, think of that. Okay, going up in the elevator, going down in the elevator, and I'm always going to write to get to that person's office. Okay. The next idea that we're going to talk about is just a generalization of slope, which is, again, something that is important to be able to conceptualize and understand, is what's going on very generally in our slope. It says here that a line with a positive slope rises from left to right, and we kind of saw that in those 2 examples, that on the first one, I had to go up in the elevator and then to the right. So that's a rising action. The second one, I had to go down in the elevator, so that's a falling action. All right, and there is a difference in the slope that you find with those. So Another way to maybe think of it a little bit is I use another analogy when I'm talking about categories of slope, either positive, negative, and then these other two. I think of being on the left side and I'm on a treadmill, right? If I'm over here, great stick figure art here, and I'm on a treadmill, this idea of walking uphill, I have to put in, I think of it, I have to put in positive effort. Like I have to make my body move for one, and I'm also fighting gravity. So I'm having to really put effort into this. So I think of that, I'm putting in positive effort, and I'm having to really work hard to go faster. Whereas on this one, if I'm starting at the left, I'm going down, right? Gravity's kind of helping me, but I kind of have to hold myself back. If I go at the same speed, or if I go at the same energy level, I'm going to go a lot faster. So I think I have to decrease the amount that I'm working to stay at the same speed. And that gives me an idea of a negative slope. On the third one, I think of, again, being on that treadmill, and I'm on the left side, and I'm just going for a stroll, right? I'm just going straight. I'm not doing any incline, decline work. And so that's just a baseline. That's given me kind of that normal effort level just to go at that standard speed. So that's a zero slope. And then we have one last one that is an undefined slope. Okay, an undefined slope. I think of it here. I can't even get on this treadmill. This looks like a rock wall. I'm not doing any rock wall climbing. So I just kind of like, I can't really get on that, right? I can't get on that treadmill. That looks like the treadmill's being stored, packed away. Some of them rotate up so they don't take up as much room. I'm not using the treadmill there. Okay, it's just collecting dust. So we call that undefined. Okay, undefined slope is vertical. So we want to classify these slopes as positive, negative, zero, or undefined. And then they also want us to find these slopes. Now, the beauty with these ones, they've given me points. I don't have to do the guessing game of does it really cross right there or does it kind of miss that one. So these are going to be easier problems for finding the slope. So let's go ahead and get started here. First of all, if I think about being on this treadmill, right, I'm having to work hard to get up there. Okay, working hard, going upwards, positive slope. And then to actually find the slope, 3, 4, 5, and over 1, 2, 3, 4. So it goes up 5, over 4, and I write that slope. But let me put it this way with this type of a problem. Finding the positive, negative, zero, undefined, take your mental image of this first one. Which one does it most closely match up with up here? It's going upwards. This one's going upwards. That means it's positive. Okay, the second one, it's going flat. I don't remember if that's zero or undefined. Oh, look, this one's going flat and it says zero. So this is a zero slope. And guess what that means? The slope equals zero. Because if I start at this left point and I go up or down, I don't have to go up or down any, but I go over 1, 2, 3, 4. So I run 4, I rise 0. So that zero slope really came from rise is 0, slope is 4. Rise 0, run is 4. And 0 divided by anything is automatically 0. So that's where that 0 comes from. The next one, it looks like I'm going downwards from left to right. So that's a negative slope. Negative. And if I start at the left, I realize, yeah, I do. I have to go down 2 to get to the next, to get level with that next point. And then I'm going over 1, 2, 3, 4. So my slope down 2 over 4. Well, that would reduce, so we could say it's down 1 over 2. We always want to reduce our slopes. And slope is always just a number. I have a lot of people later on that'll want to say, oh, the slope is negative 1/2 x, because eventually we're going to put x next to it. That's not the case. Okay, it's just the negative 1/2. Last but not least, looks kind of similar, but the line's definitely in a different spot. It's still a negative slope. It's in a different spot, but I still go down 2 and over 1, 2, 3, 4. So down 2 and over 4. That sounds like the same slope as before. So it's negative 1/2. Okay. Now, if you were to think about what the undefined slope, how we kind of figured out the zero slope, if you think about the undefined slope, if I find 2 points and I try to find the slope between them on the graph, I might go up, say this is going up 4, but I go over 0. So I'm going up 4 and over 0. If I write that, and I try to do that in a calculator, it's going to give me an error. So if you find your slope and you get error, that means undefined. Okay. All right, hopefully all that made sense. If you have any questions, make sure to put those on the left. Otherwise, have a great day, and we will see you in class.